gave you a packet that said, paper that said EMP packet on it. Yeah? You have this? If you turn on the back and you look at number 7, the last one. Number 7 is a conservation of momentum problem in 2 dimensions. It says a radioactive nucleus at rest decays into a second nucleus, an electron, and a neutrino. That's 3 things. The electron and neutrino are emitted at right angles and have momenta of 9.3 and 5.4 respectively. What is the magnitude and direction of the momentum of the second recoiling nucleus? This is a great example of vector addition. And this is a relatively simplified version of what we just went through. If I'm doing conservation of momentum, it's a before and after picture. So this is my nucleus before anything happens. V equal to 0. Then I have an after picture where, according to this, the electron and the neutrino are emitted at right angles. Since I'm setting it up, I'm going to choose that the electron goes up, E minus, and the neutrino goes right. The symbol for a neutrino is nu. I know that the momentum of this is 9.3. And I know that the momentum of this is 5.4 times 10 to the 23rd, right? Negative 23. I'm just going to keep it all in the same magnitude so I can drop the times 10 and just add it to my final answer, right? All right. Because of the fact that the total momentum of the system is 0 before anything happens, then the total momentum of the system afterwards has to be 0, because that's how the law of conservation of momentum works. So if we think about the fact that the electron plus the neutrino are actually yielding a vector that points up and to the right, then my answer for the rest of the nucleus should be something that points down like that. That's what we're trying to find, right? And so the key is to take these 2 things and determine their vector addition, and then take the exact opposite of that, right? And so I'm going to redraw this as an actual vector addition as opposed to just things exploding out from the center, right? Which means that I'm going to draw 5.4, and then without moving my pen, 9.3. This time I've drawn it much more to scale. 5.4, 9.3. The summation of those 2 vectors is this hypotenuse. So if these are perpendicular to one another, I can do a squared, b squared, c squared to get the fact that this value should be something in the neighborhood of 11, 10.8. But this is the positive value, right? It's what these 2 things are added together. So if this solution was 10.8 at this angle, then the total momentum up here wouldn't be 0, right? Because I want this plus this to be 0. Well, the key there is recognizing that the exact opposite of any vector is its angle plus 180 degrees, right? Because if this is theta, and I can use the trig functions to find theta, which in this case works out nicely to be 30 degrees, then if I add 180 to that, I will have the exact opposite direction pointed down this way. Because 180 plus theta gives me the proper direction of going the opposite way. Which is what, 210? Inverse tangent of these, yeah. Which actually, I think I have these reversed on my answer key, so it's not 30 degrees, it's 60, but you get the point. So the key there is that this plus this is 0, right? That's what we're doing. And so that's basically like a condensed version of vector addition backwards. That makes sense? Does anybody have any questions?